So yesterday we learned about how we can use the prompts and different types of prompts, and then also we also before that learned about the Python language, and then we saw examples codes around the Python language, and then today the goal is to start utilizing from today onwards, start utilizing Python language and whatever we learned so far to build systems, or maybe also start to go into the real world implementation of GenAI use cases. So all the tools that is needed, we will start from now on because now we are equipped with the language part. So I'll share my screen and then we'll start. So what we will do is first we will quickly go through one topic that we said we will get back to. One is this, that topic is about the developing agents using Copilot, but then we wanted to also use the tools capability. So far, the agents that we developed here in our Copilot, this did not call any external tool. This was just syntax or instructions, and then we using those instructions, we were able to get the LLM do whatever we wanted. So now what we will do is we will basically start to incorporate tools within these agents, and those tools we can write in Python language, and it can be from any tool, and we know now how to write code in Python, so we can use Python to write these tools. So example, uh, what I will do now is I'll show you one example where we have this agent. Let me close the previous sessions. So again, if you forgot how to create agents in the Copilot, you open the chat window, click on this settings icon, click on custom agents, then click on create new agents, choose the folder GitHub agents, and then type the name. Let's say dummy agent, dummy. Just type dummy, and then it will append dot agent dot md to it. And then of course now this you can give instructions to this agent based on the same form as we used yesterday, like the prompt format. We know now the different parts of the prompt, like role, context, input, output, and examples. In the same format, you can build this agent, and then you will be able to see this agent here. When you click it, you can then talk to this agent. In the same line, what I have done is I have created a simple calculator agent to explain you how the flow works, how the tool invocation could happen. So this is a calculator agent without a tool. It will not use tool. So it will try to just do the work based on the LLM and the agent instruction. So if I use this particular one, calculator with no tool, and just say, let's say 6 uh, minus 2. Now it will do the calculation 6 minus 2, and it says 6 in bracket the operator, and 2 equal to 4. Same way if I say 78 divided by 3. So it automatically identifies what operation it has to do. It does the operation, gives you the output. But it is not using any tools. You see, the tool section is empty. Now I will get the same thing done via an agent that will use the tool. So calculator with tool. So if I write the same thing here, 6 minus 2 This will go to this agent now. It will invoke this calculator tool. Come to this tools folder. Come to this calculator.tool.md file. From here it knows the name calculator tool. It will understand what this calculator tool file should do. It will look for this file calculator.py and calculate function. So it will come here calculator.py. In this it will go to calculate function, and whatever expression I passed, it comes here and it passes accordingly, finds out the two operators input output. Based on operand it finds out the logic to apply, and it then gives me an output based on the format I asked. So here it just says in, here it just says description to this is the tool to use. There can be many tools, that's why it's minus sign here. You can enter and give many tools here. Input can be in this expression, output it shows like this. So for operand, so operation, addition, input 7 and 15. So what it does, it invokes the tool .py file and it does the calculation and gives us the output. So if I do now 78 divided by 3, again it will do the same thing. It will invoke the tool and do the processing and we will get the output. So now it looks to be a very simple agent. But now imagine with the tools capability, you are able to, the first thing, this agent is now using the brain of Copilot, which is this LLM. And then it is using my tools, whatever I gave. And we know so far that the agent is simply like a human. If we draw an agent, we saw the different parts of the agent. Agent can have different tools. Agent can have memory of its own. And agent can also done a plan work. So maybe it can connect to a file system or database directly also. But it's preferred to create tools to do those connections. And finally, agent uses the brain, which is LLM, to get the task done. So now we ask the LLM to agent to calculate something. So first it needed, let's say 78 divided by 3. So first it had to find out what is it. So it took this input, went to LLM to ask what it is. And then LLM told this is about an arithmetic operation. So then agent looked into its file and found is there any tool. Then it found the tool. Then tool description it found. And then from the tool description, it found the actual file that does the calculation, the Python file. But then this input, output, and this operator, what needs to be done, all was invoked via LLM. LLM helped the agent to understand the which tool and what operators and operands needs to be passed to that tool. And then the tool did the execution and passed it back to the agent response, and the LLM formatted it again as per the instruction that we have in the instruction file, that it should print something like operand, operation, division. The formatting also was helped by LLM only, and then we got the response. So now you can build your own many tools. Let's say if you are building an agent for doing stock market analysis, or let's say any impact analysis like SWOT analysis and things, you can build a tool to connect to news media for a topic. You can connect to summarize. You can create another tool that will summarize these things. You can connect it. You can create another tool to connect to database. You can create another tool to maybe do the response. Maybe sending an email. The response sender should be sending an email. Give these tools names. Create these tools in this tools folder. Create the corresponding code logic also here, and then create that agent let's say the SWOT analysis agent file here, and in that start to mention the tool names. And when you see here, you will see the SWOT analysis agent, and as soon as you type the instruction, it will automatically know based on your instruction which tool to use and what operation to do, and then it will continuously pass on the data to the other tools whichever it needs during the execution flow. So now the PR agent that we built, it is just simple, right? We had to bring the code and put it somewhere in local, like here in the code folder. We have to keep the code. So instead of doing this now, what you can do is simply create a tool file here that will connect to GitHub and download the code and keep it here and refer that tool in your PR agent tool section. Here you create a tool section like this, uncomment this section, refer that tool. So it will first download the code. If the code is not there, then it will do the review. In this way, you can also now create tools to connect to your existing database, connect to your API, connect to your, let's say, the Jira board, anything, and then start using with your agent. Is this part clear? How to use custom tools now? Yes, Kinshuk?
Yeah, so we have created a agent calculator one, and it is going to perform the operation inside this tool.
Yes. So tool is like consider this LLM as a brain, only human brain. Now the tools are like the things the brain needs to perform action, like the hands and the legs. You're creating these are the tools. The leg and the hand is also a tool, right? Because without this, even if the brain says walk, if the legs are not there, you can't work. So now you created the tool like legs, and then you said if you see any threat, then you have to run. So when the brain detects there's a threat, it starts to use this tool legs to run. So till now we did not know how to write the tools and link it to the agent. And the agent is something that orchestrates this. We talk to agent, it talks to the LLM to understand the context of our requirement, then it invokes the right tool to get the action done on behalf of us. Like we human are there, right? We human are same way. Brain, hands, legs, eyes, nose, all this we can say are the tools. Is it clear?
Yeah, that means that the calculator.py file is the just like a hand or leg that is doing the actual calculation.
Yes. If for this to keep this example simple, I used to do it calculation, but you can use to do it to get weather information, connect to Gmail, connect to Google Drive, connect to AWS S3 bucket, connect to maybe log analytics, or connect to a Jira board, whatever you can think of, and connect to encyclopedia to do some findings, or maybe connect to APIs to place order on your broker platform. Anything you can build tools for that, because LLM they don't know how to connect. So you build tools, and then agent uses the tools when they think it's needed, and LLM how they come to know when it's need which tool is needed. These descriptions you give, right? You give a lot of description. You give in the tool MD file. You wrote when this tool should be used, and then you give this tool link to your agent. So now when agent has many list of these tools, when it goes and asks the LLM, the agent asks the LLM which tool I should use now because I have been given with an arithmetic operation. Then the LLM goes and checks all this description. Then it comes to know, okay, this is the most relevant tool, and it will call that tool for you. Got it?
Yeah, got it.
Okay. So I will commit this code. This is a simple example which shows the link. now with the agent file and the tool file and the actual tool code, so you can start to use them. And next, now we will move to the next topic. Next topic is we saw also yesterday how we were connecting from our local code to Gemini. This is we saw an example where we were able to connect to the Gemini LLM, which is exposed by Google. So you need basically an API key. So you go to AI Studio Gemini and then create an API key, and you can use that API key. This is the code which just uh, goes to Gemini, and we ask it with the system prompt that it should act like a health advisor, but I've also modified it to now act like a software architect, and it will design suggest me based on the requirement, the architecture part. So if I run this now, and you all now you already know how to connect, create a virtual environment and do keep install of the libraries in the requirement txt. All this we covered yesterday. So now if I run this pilot, I say Gemini Py, it will ask me my requirement, and this time it is not acting as a health advisor coach, but instead it will act as a software architect. So I will say give best design for e-commerce app. Then it will think around that no direction, and it will now it is connecting to what? It is connecting to the Google Gemini model, this one, using this Gemini API key, which is freely available from here, and I I can find the Gemini model from here. I can go to all models. Which models are free? I showed you yesterday. You can use that, and it is this model is not running on my machine, which means I have to. Uh, if I cross the free limit, I also have to pay money to Gemini, because Google, who is running this model. Running this model needs a lot of GPU and processing power. That's why they charge you money. But via API, I was able to connect, and then this is the architecture it supported. So it says, as a virtual architect, I approach an e-commerce platform as a platform single app, but this. For modern high growth e-commerce, I recommend use microservice architecture, deploy on cloud native systems like AWS, GCP, Azure. High level architecture is this. There should be API gateway and this and that, and the data strategy should be this. Design patterns should be CQRS, and other things should be followed. Like whatever we follow in the real world, it created that architecture. So same way, we can also, this is the code to connect to DeepSeek model. If you go to DeepSeek website, you can create the token and you can use the DeepSeek model. So DeepSeek API. So you can go there, but DeepSeek is not free, so you have to pay, and then you will apply for an API key. They will give you an API key. Use that API key, and then you will be able to interact. So here is the code to connect to DeepSeek, and then with DeepSeek models also you can get the answers. So again, we are providing system. Uh, the role is system, which means prompt type, and here the role is user. This is user prompt, and this is system prompt, and then you can also use this DeepSeek model. And here's the API key. There's different ways to provide API key. One way is the best way is keep it in the environment file, load it like I loaded here, just load env, then load it like this and use this here, which means if you have to in future change it, you just change it in this file, and it works for all other places. Same way, if you want to use, let's say, Grok, you can connect open. I'm not showing open AI that model, but you can also connect the open AI API key. They will also charge you money. Minimum is I think $5. Then you will get an API key, and you can use the API key and the other models, the GPT models they have to connect to their API, and you can execute your requirements. So you can just you go to their website, you can find the code also how to connect. Then there's another free one which I have for you, which is Grok, not the Grok which is from Twitter. It is Grok, GROQ. Grok Cloud is a third party which also provides you different API keys, and it also provides you different playground models. Different models is provided. So, and again, if you go there, you this is how they say to connect. Let's say if you are using Open AI, because Open AI models are also hosted here. So you can use this code to connect to this Open AI model. But then, of course, you have to install these libraries first. And in installing this library, you have to put it in the requirement txt, like Grok for Gemini, this for OpenAI, this, and these are Python that we used. I will show you for the Ollama. I will show you in some time. But these are externally hosted model. So let's say I will now use a image OCR model from Grok, because Grok is a third-party platform which hosts this kind of models. So it will use Grok API key, and I'm using this Meta Llama Scout Instruct model. And what I'm saying is, what is this image about? Identify the image, and I've given just an unsplash thing here. So if I just type now here Python Grok image OCR, one second, I encrypted it. You will see it will send this image to Grok hosted model, which is this one, Llama model, which is from Facebook. And this is describing that, you see, it gave me a response in an object, chat completion message object, and the content is this. So we have to parse it ourselves. But when what it did is, the image depicts a scene of a person sitting on a large rock in the middle of the body of water, likely lake or ocean, during sunset. The individual is dressed in casual attire, wearing baseball cap, hoodie, jeans, appears to be a moderately simply taking in the view. So key element, person sitting cross-legged, and all this. It is describing that. Let's check if it is clearly describing it properly for us. So what you can do with these kind of models, you can, the OCR or the image recognition model, you can basically use it to build different kinds of application. You see, this was the image which I provided, and it described everything. It even found a person is sitting cross-legged. So what you can do is you can do the OMR correction application with this. You can build something like that, or you can uh, build an application that can read doctor's prescription, which is not readable easily, or some other use cases around that. Similarly, there are many models here, speech to text, text to speech. Many models are there, but they charge differently. So let me show another example of Grok Cloud hosted one another model, which will now convert, let's say, this Grok TTS text to uh, text to speech. So it says welcome to OPS text to speech, this model. And again, it is using this. So it will store the file in this format. So what it will do is, it will basically convert this text into an MP4 file, or the and then we can hear that one. Same way we can convert a sound to this. So if I go here now, it has created this one.
Welcome to Orpheus Text-to-Speech. This is an example of high-quality English audio generation with vocal direction support.
I'm not sure if I was able to hear this. Did you hear this? Hello? Was it audible to you, the audio?
Yes, yes, it was audible.
Okay. So now you can think of other use cases. Take the text and convert it into audio in the streaming form also. Everything is possible. And then you can take, there's also models to convert from audio to text also. So these are different grok models you can use. Next is about how can we deploy models on our own servers so that we don't have to pay money. For all this, it is they will charge different amount of money. The pricing, if you go to pricing, there will be pricing for different kinds of models. So if you go to Grok and here they have this plan, let's say there's a dev plan, but if I go to specific pricing, these are different reasoning models, GPT models. These are Llama models. This is a Vision Llama model that we just used, and this is Whisper model also for text only, audio, and audio to text. They are introducing new models nowadays. Kimi 2, Quen, but we can install all this model on our local computer also. But we need a huge computer with GPUs. With CPU it won't work. Small model will work. I will show you which ones, but not the big ones. So let me go and see if we can find the pricing. So if I choose this model, I can choose the different model names here and I can go and copy paste and use it. So they have request and tokens, what is allowed, all those limits they have here, but then pricing wise, you have to check uh, what is the different pricing for this because it's not all free. To some extent it is free, but they take money from you. If you type on Google also, you will get the link. So here they say the GPT, this particular model, they charge this way. Input token, per million input token, they will charge $0.075 and per million output token. Again, token are nothing but these words. Words. Yesterday we also learned about this. The words that we sent to the prompt that we sent to this guy, the LLM, that is the input prompt or the input tokens are calculated from that. So each word is broken down. Each word will become one-to-one token. And then response, if it is a reasoning model, it will give a big response. If it is a non-reasoning model, it will give a small response. But you can also turn off the reasoning of a particular model. And response will have this much per million token. So if you build things, so if you see Kimi models are a little bit expensive, so you can compare. And these are models which is hosted on this cloud platform. So it's a third party platform to host your models. They will take care of all the GPUs and performance. You can just go ahead and use them. And these are text to speech models. We just used this one, Orpheus English. And this is the amount they charge. And speech recognition, the whisper model, it recognizes your speech. Prompt caching is also provided. So there are many things they provide as a cloud provider. We will see other platforms also in future who provides us GPU on rent, so that when we will do we want to do fine tuning, and we will also train our own model, right? We will also create our own LLM. At that time, we can take these kinds of computers, which are all GPU computers, high power GPU computers. So you don't have to buy anything. You can rent them, and you can train your or fine tune your models. So this is one GPU per hour. It charges $1.5. Same depends upon how much VRAM you want to use. So these are different processor, and based on that processor, and then you have different compute VRAM based and CPU based combination of different pricing. Most of them at least needs A100 type of processor and 80 GB of RAM. Minimum they need nowadays to do anything with large language models because they are so huge. Similarly, there are many other platforms who provide you compute capacity on that. So now coming back to, can we run the models locally? So there are different tools nowadays are made available. Before we go there, this is a documentation on the VS Code uh, custom agents. So if you type VS Code Copilot custom agents, you will get this particular documentation where you can see the steps that we did. They are explained here. So now I will go to Ollama. Ollama is a tool using which you can create your own. You can run the LLM models yourself in your local computer on different servers. So, like here, Grok was running on their cloud. You can also create your own cloud platform and you can run this model. The cloud platform, you can say, I also want to sell hosted models on the API based with the token mechanism. So, Ollama, you can install Ollama on that big server, and then you can deploy the different models and provide it via API to the people. So that is how you can do it. So this is, you can download the Ollama, install it. The Ollama has so many integration nowadays with different other tools. But when you download the Ollama, you have to register it and then you download it. After that, you can have different models that you can install. So on your computer, let's say you go and download, and then you can basically just say Ollama serve, and then you can also do Ollama run and the model name. It will download the model from there and run it on your computer. For me, let's say Ollama is running now. This is my Ollama, which is running now, and I'm using the smallest model because I don't have GPU. But you see there are many models which you can download: DeepSeek, Gwen, Gemma, GPT, OSS. There are many models. You will be shocked to see how many models they have. They have vision models, thinking models, and all have different variations. So all of this you can download and run it on your local. No need to pay money to any company. But the only problem is these are quite big size models. So because the LLMs are based on the parameter, right? Parameters are nothing but different areas in which the model has been trained to think and reason. So you see, 3 billion parameter model, 8 billion parameter model. The you can just simply say these are the number of neurons the brain has. So more neurons, more thinking capability and learning capability, understanding capability. So, but then to run those heavy parameter models, you need to have that much compute capacity. So now, for with my machine, I just let's say use this one. Quen model. This is I think from Alibaba, and I will just ask it to write a Python code for fetching code from GitHub. So this is running in my local. It is not going to cost me any money. So it understood this requirement, and it is trying to write that code. So if I host this on a server also, where I can have a good CPU, or it's good if I have GPU, then I can run many other models. Then I can call this one all the time. I don't need to pay money for the models to external providers. So it is still doing all this planning strategy, other things. We'll come back when it writes the code, but it is all doing local. So now I want to also use this model locally. This is a UI provided by Ollama themselves to chat with the model. Otherwise, you can also chat with the model from command prompt. So I can say command prompt. So if I have the Ollama installed, I can go to command prompt and do the same thing. But they have provided now UI. So it wrote the code now. So if I just say Ollama list, it will list me all the models that are installed at this moment. So I can just say Ollama run and I give the model name, then it will start to run that model. Maybe this one, if I just type this one. So it will run that model for me. If it is not there, it will download install. If it is there, it will run that for me, and I can chat here itself. You see what is the capital of India? The capital of India is New Delhi. It was established on whatever it will give now. So this is another model, small LLM2 model, which takes 1.8 GB. I am using Quen 3 0.6 billion parameter model, which is 522 megabytes. But you can also use other ones. All of them are available, but the only issue is the compute and the size, the CPU. So it will not be that fast. So here also it wrote the program now. Wrote the program to fetch the files from GitHub. So now if I close this, the Ollama is running in the background. Let's say I want to connect to Ollama like I was able to connect to Gemini or Grok or DeepSeek or OpenAI. So it's simple. I can just say Ollama, this one. This is a better example. Here you have to provide the URL. By default, it finds that it is running localhost, so it finds it. But if you host this to some server, yes, Kinshu? Kinshu, you have question?
Yeah. Is it using the local compute power to
Yeah,
generate the response?
this is everything local. Ollama, what I did is
Yeah, as you mentioned, like we have downloaded these models to our local. So whatever response is getting generated, it is using the CPU, RAM, everything from our local system only.
correct. So there are two options, right? Either you host it somewhere, like you watch movie. Either you go and watch it on Netflix, or you go and download it and watch it on your computer. So when you watch it on your computer, it uses your processing power capacity, everything resources from your computer. The movie is same. The same way, if you are watching it on Netflix, then it is using Netflix server. Hence, you pay money for that. It does all the streaming, everything. So in this the world of LLMs and large language model, vision model, it's same. Models are made available. You go ahead and deploy it on your local computer or any VPS server or any cloud. Let's say I can also go to Azure cloud and deploy these models, and I can start to call them with API. Or I can just go to that model provider, like for Gemini models, Google, for OpenAPI models, go to OpenAI models, I go to OpenAI, or DeepSeek models, I go to DeepSeek. So I can also do that. Got it?
Yeah, so just one more question that does it requires internet or it can work without internet connection?
No, no, why? It's not going anywhere, right? It is in your local, so no internet required. Once you have downloaded and running your model, it's done. Now it's in your local computer. So here, now I will talk to the same Gwen model, Gwen model which I have installed it here. It's running here on local Ollama. Now this program I will run, and you will see what happened. This program will now start to act as a health coach. So I will say Python. At the earlier, it used Gemini model to do this operation. Now it will just use my local hosted 1.3.6 billion parameter model, and its system prompt is this. User prompt I have given this. So now I will say Ollama. You will see it's going to take a little bit more time because it is going to follow my local model, and local model processing will take a little bit more time because of my machine capacity. Hence it is taking time, but it is processing it. It's not like it has stopped. Let's wait for the response. Same way you can build systems and other things around your own locally hosted or cloud hosted personal models also. Yes, see, now it came. So it says it also it's a thinking model, the Quen 3 model that I used. So user is a software engineer who wants to keep fit. Let me think about how to approach this. So first I need to address the concerns, engineer long hours and sedentary work. All this it understood, and then finally it said, as a software engineer, it's natural to balance your work life with this. Considering sedentary lifestyle potential physical demands, incorporate short, regular activities, to use technology for exercise, prioritize recovery. All this it suggested me. Got it. And the intelligence this it used now is my local computer hosted model intelligence. And which model? Quen model. Because asked it to use Quen model. I can ask it to use other models also because I also have installed other models in my local. I showed you, right? Is it clear now how you can deploy host your own model locally or install Ollama on a server like a Linux server and install the model there and call them. Just change the IP here of that server and it will work.
So whatever port we'll give in that port only it will take, or it is somewhere
If
preset.
default port is this, you can change the default port also. This is default.
Okay.
Okay. Now,
Yes.
now we saw using LLMs of different companies, different way, hosted on their network, hosted locally with us, and accessing programmatically. But then there was one problem that we see that every time we have to write code to connect to that particular LLM provider, we have to go to their portal, find the code of their type to connect. So there is no systematic or let's say one way approach to do things. So that's where this framework comes into LangChain. And this is a very popular framework whenever you go up to apply any job in GenAI. LangChain, LangGraph, LangSmith is a must. Every company uses it. It's same like Spring Boot in Java world, or nowadays Fast API in Python world to build APIs. It's exactly same. So just imagine if you don't know Spring Boot and you go to give Java interview, then what happens? Same way it is for LangChain. So what LangChain does, what problem it solves, let's first understand why even LangChain is needed. So LLM that we saw alone can only do what? Text generation based on the prompts that we provide. This is what they can do. But in the real world, what we do? We just don't do text generation, right? We do a lot more. So the problems that LLM encounter, they cannot, LLM directly cannot search your database for knowledge. It cannot directly read PDFs, cannot call APIs, cannot remember the past conversation. So all these are challenges that the LLM faces. So we needed something. It's not only LangChain, we could build things around this ourselves. But then if we have to build things around ourselves without LangChain, then we would have to write many tools for doing API calls. We have to construct the prompts properly. We would have to write the logic of document retrieval, embedding generation, vector search, and memory. All this we have to do ourselves. But what LangChain does is, it's a framework, open source framework, using which, like using Spring Boot, you build enterprise Java applications. But using LangChain, you can build application powered by large language models. And what it does is it helps developer connect the LLM. Now, with the help of LangChain framework, LLMs can talk to data, tools, APIs, workflows. It can now be able to talk. So consider LangChain like a nervous system in our body or circulatory system, that it is able to connect to different parts now. The brain is able to connect to different parts, and to connect to data, whatever it needs, it has with it. If anyone wants to connect to data, the LangChain framework provides something. Same way to connect to tools or APIs, it provides different things, even for workflows. So now you can build a powerful integrated end-to-end systems like chatbots, document search system, AI agents, and other automated systems that you can even think of. You can build this because the power of LLM to interact and do things with its environment is now provided by LangChain. So LangChain solved this by providing ready-made components. Now why it says chain? The concept of chain is very simple. You can connect different actions one after another so that in output of one action becomes input of another. That's why it's called chain. We can build a pipeline of different tasks and call it as a chain of that task as pipelines. Or we can, basically I will show you how. So first, whatever we are doing till now, we are basically giving a system prompt or a user prompt. First we do that. Then the LLM takes that prompt, processes it, and then it gives us response. Sometimes response is in most of the time response is in a big complex uh, object. Then we have to parse it ourselves. Minimum thing we always do this. Give you prompt, our prompt in a particular format. We have to do the formatting. LLM passes it, uses it. LLM gives something in response. We parse it. So how LangChain solves this issue? I mean, kind of giving data, parsing, understanding, again on parsing it. So LangChain provides this ready-made modules. Let's say for prompt construction in the proper formatting, it provides something called prompt template. For memory, short-term memory, long-term memory of our conversation that we will do with the system, it provides something called memory to store those. Chain I will show you how to connect one task to another task in the chain format. Retriever is if you are building a RAG system, like when you provide local intelligence to an LLM, you need something as retriever to help convert that data and add it as a context to the query or the prompt and send it to LLM. And then the LLM responds with that particular context. So the retriever module helps there. And then of course there's a tool module that helps to connect to different tools that will be used for building agents. We will see all this in future. But let's say how many ways are there to use this particular LangChain. So in LangChain, you can simply the simplest is just call there's a class, call the class and then pass the model name, invoke that and get the response. So in 3 lines this is done, but here to do the same thing we were writing many lines of code. Let me show you here. This is what we were doing, but all this it can be now done in just 3 lines, and it can be if you change the model now to chat grok. If you switch to Gemini, only this changes. If you switch to, let's say, Llama model, this changes. If you switch to DeepSeek, this changes. Only this changes. Other part of the code remains the same. That's the advantage. So now you write code in one pattern that follows a pattern. So here what happens? You send single text prompt, model returns single response. There is no structured prompt or conversation context that we are providing because it is for simple purposes. The user prompt is there and LLM, it goes to LLM and LLM responds. It also says when to use this. So for simple type of thing, you can like here it's shown, right? You can use this for simple types of use cases like generate explanation, summarization, text generation, or testing, small testing part if you want to test the LLM. So example use cases, you can use this. So we give prompt and we get response. But what if we need to first enrich the prompt, then give it to LLM? And enrich the prompt means we need to dynamically create a prompt that has data also from our API, also from our database, and then we give it to the LLM. This happens when you build a RAG system. So this is how you do that. You basically create a prompt template and you provide the static part of the prompt and this topic, let's say, is the dynamic part. So there can be, now you can keep dynamic variables in this, and then the value of this topic can be replaced when you invoke the LLM, right? When you call the LLM, you can pass this as a key value pair, the values to be replaced. And you see, this is a chain now. You say first do prompt parsing, then pass it to the LLM, then pass the response of the LLM to the output parser for making the response cleaner. So input data, whatever we give, prompt template is formed, variable replacement, other things happens. It goes to LLM, output parser comes into picture for parsing and cleaning the response, and then the result is shown to the user. So again, we'll see examples of all this, but then it's very important to understand why we are doing all this, why it's needed. So in real world, we don't provide hard-coded prompts, right? Let's say you want to build a system that, let's say, inquiry system in a hospital. You go to hospital, and then nowadays you have receptionist and reception people are there. Assume after 3 years or 5 years, there won't be any receptionist and other people. There will be an automated machine kept. and then you go to the hospital, you just type your Aadhaar number there, and then as soon as you type the Aadhaar number, and then you type your query, what problem you have. You just type, okay, I am suffering with this issue. This system will take your input and check in its own system if you already existed in your past history, and then create a summary of whatever you had in the past with this in this hospital, and then add your new things to it, new symptoms, and create a preliminary report specifically for you, and then it will give it to you in the printed format. And when your number comes, you go to the doctor and you give this one, you give this paper, or just it even sends it to the doctor directly in the doctor system. And then doctor, when you go, doctor is just already knowing what you had problem, what you are complaining about now. So they would, the junior doctor or juniors, those people or receptionists, they won't be needed anymore because you automated those. And how did this LangChain help? How did the prompt template help? Here, when you provided the Aadhaar number, basically when you are building this system, you are writing prompts, complex prompts, and in those prompts, there are values that needs to be replaced, like your name, your Aadhaar number, your symptoms, your problems of the past, your explanation, or your diagnosis of the past, and then your current issue. So some parts of the prompt are static, and some part of the prompt is dynamic. So if this prompt template is not there, you would have to create those by plus appending this and that, what you have to do. But now with LangChain, it automatically did it for you. You just replace those values. You call, when somebody give the Aadhaar number, you call the DB, found a response, replace the name with the name, and past problems with the past problems in the prompt. And same way, you would do a lot of replacement, and then you can build that kind of system that can be useful for generating a preliminary report. Or let's say you had a certain problem and you want to get your past report, you just go to the system and ask for a report or medical report, it will provide you. You could do these things now also, but that has to be a database approach. But if you don't have database, just you want to do in plain English or plain normal language, this you can take of help of LLM and build using LangChain. So I hope you understood what problem this LangChain is solving. In this case, it solves many problems. The overall framework, you will see upcoming time when you will learn, it solves many problems. One of this is prompt dynamic prompt creation and parsing. So instead of you checking the database, user input, document text, these dynamic values gets inserted into the prompt like this. So the request was for vector DB here. It got replaced, the topic got replaced with vector DB. So you can use this to build this kind of systems like the RAG system, question answer system, report generation, AI assistant. Hence, uh, the second way approach is via structured prompt plus dynamic variables. And then third one is the chat message interface. So this is another way to use LangChain and interact with the LLMs. This is called chat message way. Instead of writing plain text, you send structured messages like this. If you send a message like this, right? What is retrieval augmented generation RAG? So because it was human message passed in human message object, similarly there is also system message. It will automatically detect the role. It's a user prompt, and what is the prompt it will identify. So there are different types of uh, classes available: human message, AI message, system message. AI message is the response that you get, and system message is the system prompt. So you can also provide messages to the LLM like this. So why this? Why do we need chat model style of interaction? Because nowadays model training and fine tuning is happening this way. That you said this, the model responded that. So if the training is happening that way, if you want to interact and get the best out of the LLM, you also have to write your application in the same chat model way. So like this, chatbots, AI tutor, customer support bots, assistants. So it will respond like this. User said this, AI said this, user said this, AI said this. Next is streaming. So you must have seen as soon as you start typing something on ChatGPT, it starts to give you the response quickly. But you saw when I was using some program, it was not giving the response instantly. Instead, it was waiting for the complete response to be created, and in one shot, I was getting that. Give me just one sec. So now this is usually what happens. We wait, and the full answer is returned. But with streaming, as soon as your prompt is typed, LLM starts processing and giving answer back, and you get answer in pieces. So prompt and LLM starts generating output token, and each token gets streamed. And where you can use this, like ChatGPT kind of style application or streaming application, live assistant or coding assistants, where you want to see things already as soon as they start to appear. So you can compare like this, when to use what kind of format of LangChain, basic, then this prompt plus chain format, then for this kind of use cases, chat, then this kind of use cases, streaming, this kind of use cases. So let me quickly show you now. So again, I've created LangChain examples for Gemini, Ollama, and Grok, which are free, all three. But you can also do it for paid ones, DeepSeek and Open API, which are the paid ones. So if I go with Ollama again, so this is, let's say, the basic one. So if you compare what is the difference between this one and just calling with raw, not using LangChain, and then trying to call, I will show you this. This is the one where you did not use LangChain and you start directly, we called it. So this one is with LangChain. It looks so simple. It says instantiate an object of Ollama LLM, from where you can get LangChain Ollama. And what is this? This is a library made available. If you go to requirement.txt, for every provider, like for Google, there is a LangChain Google Gen AI. For Grok, there is a LangChain Grok available. For Ollama, there is a LangChain Ollama available. And these two is on top of it. Should be always there. So these libraries, you add it into requirements.txt, install in your environment with pip install requirements.txt in your environment, and then you can use this classes in your own application. So now I can talk to the same Ollama using the the LangChain framework. So let me run this now. It will connect to my local models, and if I type Python, we learned the 4 ways of using LangChain to connect to our LLM. So I'm using the first one, the basic way, just the invoking, passing the prompt to the LLM. That's it. So create an object of LLM. It takes different parameters. You can click and check the different parameters it takes. Just hover on it. You say it takes different parameters: name, cache, verbose, callback tags, model, and you can say whether it should reason or not. You can say reasoning true or false, and you can provide a lot many parameters. So we have just provided two of them for now. So I will say basic. Wait, I have to be in the CD grok on Ollama, and then Python basic LLM. So now it is basically going to execute this user prompt on my local Ollama and respond me. So it is such a simple program now, and I can execute it on my local. I can also ask it to stop reasoning because reasoning takes a lot of time. Reasoning. Here you can also provide different other things token to use, but temperature is like how do you want your LLM to behave? I mean, very creative, not creative, or moderately creative, randomness that you can add with temperature. So here it says it was thinking, and then it's giving the answer in the form of this. That LangChain does this. It solves this problem. Now let me see. Here I am using a flag which is available. Reason, where the reason flag model reasoning boolean. Now if I clear this and run it again with this reasoning set to false, let's see what it does, whether it will reason or not reason. Because if it is simple task, we don't need it to reason. Mostly reasoning is needed when you are building complex multi-agentic system. Then it is to reason out its own processing steps. So let's see if this flag works. We can also go and check the documentation of LangChain if you just type here. So again it was it says it was thinking. It did not turn off the thinking of the model. You can say LangChain documentation. Just type that. So here you will find a lot of things. This is the LangChain. It's a very vast framework now, but you will be able to find the documentation. So here Ollama related things are there. So if we go to Ollama, let's say chat Ollama. So it's giving chat Ollama class, and chat Ollama class you have to find out different. So here it is model temperature is there. Tool calling is also possible. It says you can create a tool, and from here you can call the tool. See, bind the tool. So it's in this the LLM invocation will use this tool also. And this is the tool. You declare at the rate tool on top of a method and create that tool and ask your LLM to use it like this. Bind tools. So here is an example of multi-models. They say multiple models are used. Image model, text model are used here. Reason model, custom message. Reason model, custom message. So this is chat message role control thinking, content thinking. There must be something to also stop it from thinking. We have to check the library for their API reference and documentation. There must be definitely something. I will try to look for it. So we are using this one, Ollama. And here if we go, There are different attributes. We are using reasoning. Reasoning uh, think, controls the reasoning or thinking mode. Supported models. Okay. To enable reasoning mode, the model reasoning process. So let's see what are the supported models. Yeah, so it is saying it should have worked as per the documentation, but it's not working. Maybe the model that we are using, the one model, it's not supported. That's what I'm doubting now. But these are some things you have to check a little bit in detail in the documentation, and that's also your job as a agentic or Gen AI developer. Not everything will be to get done by agents or co-pilots. You also have to do something, and that's why these kind of things you have to do, right? So that's why there, when this someone says all the IT jobs will disappear or people will be fired, that's incorrect. So you still need people to write these kind of systems, look into documentation, keep the system upgraded. So now you're using one version of this. If something changes, you have to use another version. So those for those part you need people. But yeah, you don't need people to now just code. That will be on. So now if I go to the prompt one, here it's see example is there where you can use the same Ollama, instantiate Ollama LLM, use the model, give the base URL where it is hosted, and now it I'm invoking the chain with this topic. So I can also say another variable here, topic, and that's a simple input. Now I can replace this with another key here. What are vector database? So it is, I will say if example, give example, give example of popular vector databases. So now I was able to replace these two in my request, and if I run this now, it will also give me some examples because my query is now input query is enriched. So then we will look at the chat model format. This is the like how you manipulate the template. We also saw how when to use this one, the template form. Then there's this chat model I showed you, right? This is nowadays become popular. This way of calling the LLM via LangChain because the training has been done nowadays like this. The human says this, AI said that. So invocation also, if you do this way, then it is good in terms of performance. Then you can also make just Postman collection call or API call, like we also saw in Google documentation also that you can make you can call those models with APIs as well, not only SDKs. So that's also possible. See REST API. Same way, you can also call your hosted Ollama models with just API, and this is what the API is. And if you see the response now we got from this prompt template with chain. So first part was this, what is vector database, and the second part of that dynamic one was this. So it says these are the different vector database, which are popular. Chat one I showed you. Streaming is important. Now let's see the streaming. Python streaming. So you see, it started to type as soon as it got the request. It did not waited for a complete thing to be completed. So this is an example of streaming. So it's writing a poem for us. So now using this pattern, here I have provided code for Gemini, the basic way to talk to Gemini using LangChain. Again, it's exactly the same, only this changes. The prompt template way, where you can make the prompt dynamic. And then chain it like this. Then chat model way. Of course, we are loading the API key and the model name from the environment file. So this is needed. And then we have the prompt template. So this is for Gemini, this is for Grok, same way. So now you see with this things you can build applications which can be of great value in your organization. So I think we'll pause today's class here because I have some other work to attend today. But then you can already, I will give you this code and examples and other things. You can already go ahead and play around with it because I showed you now only the free ones which you can use. So you don't have to pay any money. Then there is another free one called Open Router. Open Router is another platform like uh, Grok Cloud. Here also you can create an account and log in. So let me, and then you can basically use models, some models for free. So now it says buy credit or create API key. I can create an API key. Let's say test. So this is the API key they gave. You can use it. Please copy and write it somewhere. You will not be able to see, and you can use it with the code. So if I go to here, I can say open router key, and they have the TypeScript format. Here's the Python format. So let me copy this. we can go. Here we can. Now I can create open router, let's say demo. Fine. And paste this code. You know how to customize it now, things. Just that I have to. It is basically just simple. It's making the API call, so it doesn't even need any extra library. So we will use this GPT model. So Open Router is providing GPT model for free. See, also Llama, the blog was also providing some GPT model for free. So here, what I have been do now, I can here shift plus. I think I have to do it in a right way. So here, first we need to get these two. Also, let's take the whole thing. Load the keys from environment variable. We don't need this one. We need a open router key. Okay, done. They're not needed for now. It says these are optional, so we can even ignore this. Now, if we run the response, let's print the response. Then something extra got deleted here. Okay. Now, if I print the response here, let's see the open outer we get. Ed dot Python and open router demo. So if I hit this now, so now my local code is going to make the call, and it says API key option must be either passing API key to the client or setting open API key environment variable. Okay, so it expects this name to be like this, not open router but open API key. This is the how it expects the name. So let's screen. Still giving error. Let's see. Wait, here is the SDK provided. What are these ones? to copy this one. Using OpenAI SDK, it's using that. But then we have to now install OpenAI also. So you have to take this OpenAI, put in requirements.txt. But OpenAI is already installed, so no worries. We have that with us. Copy these things again. Now API key. It will need this also. Let's see what happens now. Now when we hit this, by setting the API client must set the option API key to client or setting open API environment variable. It's already set. Oh, wait, the name is incorrect. Open API environment variable. Yes, so now this gives us the right error. This is now it is able to connect. It says error message. This request requires more credits, maximum token. So it's saying it's not allowed. So basically, this is not this one. The token that we generated, we cannot use this freely. The API key, it is not in this particular API key. You cannot use OpenAI related free models. That's not allowed. So we have to check which models are free and allowed and then only use that one. So here it says these are the models available in this open router AI. But now I have to check if anything is free. There were some free models which you can also try. Otherwise, I will in the next class try to find some free models which you can also use from this. But then for now, at least Grok you can use, Grok Cloud, Gemini models you can use, and LLM Llama models you can use. These are three options of free that you can use. But for if you want to use the paid ones, you can link your credit card and use it. Like here, I also have demo of OpenAI, like GPT. But again, it will ask you money. So if I say, let's say Python OpenAI, so it says the environment variable should have this. Okay, let me copy paste that logic to set the environment variable. This is the standard code to set the data from the env.env file to environment variable for the program run. So you don't have to always go and set it in your real environment variable. Yeah, so now it's saying incorrect a key provided because now we provided the open router key. But if you go to open AI and generate a key, AI API key, and use it here, then it will give you the same error like we got. It will say that tokens are not available, you need to buy. So log into API platform. So here you can say API keys, create new API key, test. So if I now replace this one, right? Open API key. Now we will get some other error saying the amount is not there. Recharge your amount. Oh, this worked. So they are allowing free also little bit. See? So open API somehow is working for free also. The open AI, the GPT models. Which model I am using here? The GPT 4.1 Nano. GPT 4.1 Nano is free with the API also. So that's also good then. So it says never used. If I refresh now, it will be used now. It will give the time from now. Created this, still not reflected. But this will get updated, and every platform provides you the usage. So you are seeing it here, right? You will be able to track your usage of the API keys, the number of calls made. They have some kind of dashboard or platform for that. Even Gemini has that. Open Router has that. Cloud has that, so that you can check your uh, usage properly, who used when, and other things you can check. It's giving claim free tokens. Oh wait, I think I have a balance. That's why it allowed. I have a $5 credit balance here. Maybe that's why it allowed. But give it a try for you because it's also giving claim free tokens. And you may get some tokens free for open AI. And then you can use the GPT model from Chat GPT, the different Chat GPT models. Any doubt until here? How to use different platforms, get API keys, use them directly with their provider, the code, or now also with the help of LangChain. Any doubt until here? No doubts? There are no
Just
doubts.
provide all the links for these platforms where we
Sorry?
can generate the keys.
You just have to type the platform and the API key, platform and API. I can also put it in the chat. I'll put it in the chat so you can use that, or I can put it in the link, the documentation. Best would be I will put it here in the notes file. So these are different platforms which you can use. So settings models. Oh here. Yeah, and these are there, and then of course you have Ollama also, but Ollama is like you have to install it, download and install. So now you have many platforms on options to use large language models in your use cases. Okay, then if there are no doubts, we'll connect next time. For now, I'll share the recording on the same channel, and then you can watch it. You can do hands-on and play around with creating more GitHub Copilot, more agents using tools now, and then also connect with the LLMs directly, but also using LangChain, and then try to build something of your own. In the next class, we will now work on top of it. We will see the next other topics of LangChain, like using agents, and then LangGraph and LangSmith for monitoring, tracking, those capabilities we will use. Any last comments or doubts by anyone before we close the class? Okay, then have a good day. See you next time. Thanks everyone.